Title of today's last lesson, Multiplying and Dividing Mixed Fractions. And just a reminder that tomorrow's pre-quiz does not have mixed fractions on it. It's all real simple fraction type questions, but maybe some BEDMAS, okay? So all that stuff from before today. Well, I'm actually going to start off very weird here. There's a weird question at the start of your homework that I want to get you ready for. Oh no. It happened again. Well, I'm not going to waste your time. But I don't need the video because it's not going to happen because my screen has... Oh, wait a minute. Maybe it is working. Hang on. I got to unfreeze the screen. Oh, we're back. There we go. Okay, so we are going. I'm glad. Okay, so it'll seem like I'm getting sidetracked here. First two slides you're going to be like, what are you talking about? What does this got to do with multiplying and dividing fractions? But I want to show you this big idea, and it's in your homework. There's a couple of questions in your homework like this. This actually goes to mental math. I want to show you a little bit about mental math. Earlier, I did a couple of questions very quickly on the board with some multiplication in there. And if you're watching closely, I saw a couple of people eyebrows raised like, whoa, how did you do that so fast? It's not because I'm smart that I can do multiplication in my head. I'm just experienced. And I know some things maybe that you don't know about multiplication. Step one, to being really good at mental math. Get up to your 9 times 9 times tables. Back rocking and rolling like this. You know, like if 6 times 8 doesn't come right away, that's going to make this difficult. But if you can get up to 9 times 9 in your head, which shouldn't be too bad, really. I mean, at some point, probably you were supposed to have that all in your head. Then, questions like this can be handled, say 7 times 24, can be handled in your head, with just a little mental picture is all you need. All you have to do, and I know about the algorithm. I know 24 times 7, and you do the thing and you carry things. I know all about that. This is about mental math, about being able to handle it in your head. Well, we use area model, it's called. It's so good. And what's better about area model is it has huge algebraic implications. You're going to see in this course that the area model will be handy for other things. So it's not just about mental math. If you don't care about mental math, that's okay. But it has other applications as well. And it certainly has applications in area. So let me show you one. Here's what you have to picture in your head is a rectangle that is 7 by 24. But I'm not going to make it 24 because 24 is too hard to do in my head. But I can break the 24 into two things that I can handle. First, the 4. And I hope you know what 7 times 4 is. And if you're like, well, I'm not real good at those. Well, then that's probably the end as far as how good you're going to get at mental math. If you can't do 9 times 9 in your head really quick, up to 9 times 9. The good news is, for most people, when you start reviewing them, 1 to 6 is usually pretty straightforward. 9 is like really straightforward. So really only you got to worry about is the 7s and the 8s. Yep. Okay. So 7. What is it? I hope I gave you enough time. What is 7 times 4? And does that come up real good for you? Okay, so that's good. If you can do those in your head, you can do all this mental stuff in your head. Then this part's 20, which actually, if you can do up to 9 times 9 in your head, 7 times 20, all the 10s, is pretty straightforward. What's 7 times 20? 140. So, if you saw me do this in my head, mental math-wise, you'd see my mouth. Well, with a mask on, you won't see my mouth moving, but normally you'd see my mouth moving. So I'll use my hand to imitate my mouth of what I would look like if I was doing this. I did one earlier here. I was doing this, right? Yeah, this one exactly right here on the board, where I multiplied 8 times 15. And if you had been watching me, you didn't because I was faced this way, you would have seen my mouth move. And in my head, I'll do this one. 7 times 24. I would have gone 7 times 24, so that's 140. And I sort of say it out loud in my head. Then I go 7 times 4 is 28. And because I said the 140 out loud in my head, I can remember it. And then I can do 140 plus 28 is 168. It's not quite as easy as I'm applying here, except it's way easier than that if you practice it a little bit. Like everything. When you first do it, it seems impossible. And then you practice it, and boom, there it is. Reminds me of teaching my kid to ride a bike. don't know if you ever taught someone to ride a bike. Oh my, what a disaster. You're just staring at them going, just, you turn the pedals, but they can't get it figured out. And then all of a sudden in one moment, it's like it happens in 1 second. He's 4 years old, he went from, nothing, to whoosh. I'm like, whoa, there he goes. And then he was like booting around the rest of the summer, you know? Once you get it down, it's no problem, but it's hard to get started. Same as this. So if you're up to single times single that you can do in your head, practice on some single times doubles. Keep some kind ones for a while. That's why I just said don't worry about 11s and 12s. I do them all with single times double. I'm not even sure I have them memorized anymore. I just do 11s and 12s using this. Well, that's good. You can work on that. But this is better. Watch this. And I'll keep the numbers under control so that we can sort of handle it in our head. Okay? 23 times 12. Well, 23 and 12 are both unfriendly numbers. You might think that 12 is fairly friendly, but for the purposes of these examples, I'm going to approach any two-digit number as if it's not friendly. Boy, if you're thinking, what does this got to do with fractions? You're right, yeah? My third example will be the fraction one, okay? Yeah? 23 times 12, I'm going to take this 23 and break it into 20 and 3 in my head. Not hard to do. Then I'm going to take the 10 and 12, the 10 and 2 out of 12 and break them up in my head. And then all of these multiplications are ones you can do in your head. 20 times 10, 200. 20 times 2, 40. 10 times 3, 30. 3 times 2 is 6. And the answer is 276. I can add those up in my head fairly quickly. Now, if that blew by and you're like, oh, there's no way I can do that in my head. You're right. You're right. You got to be able to do these ones first. Once these ones you can handle single times double in your head, no problem. Double times double is not far behind. Yeah? And then anything up to 99 times 99, you've got a shot at doing in your head. Yeah? Why do we care? Why do we care about mental math in this day of calculators? Boy, it just makes doing your homework and doing math a lot faster when there's certain things you don't have to type in your calculator every time. If every time you see 3 plus 2 you have to type in your calculator, homework's going to take a long time. And every little bit you can stretch your mind helps for later things. Don't buy any of that? That's fine. Later on, very soon, grade 10, these won't be 10s and 20s. These will be X's and Y's and stuff like that. And we've got to have an image of how we're going to handle all that. And this image is a great one. Right? So there is applications further past mental math. You're like, blah, blah, blah. Okay? Tell me about the fractions. Isn't that the homework? Tell me about the fractions. Okay, here come the fractions. 2 1/3 times 1 1/2. And yes, I have chose very kind fractions. This gets difficult if the fractions aren't kind. 2 1/3 can be broke very nicely into 2 1/3. And if you haven't been copying things down, you probably want to get this one down because there's a homework question that makes you think like this. And so you're going to want to go back to my example and go, what did he say again about this? As you try and handle the homework question that tries to do multiplying mixed numbers with a picture. And then this way, 1 1/2. So step 1 of multiplying mixed fractions with pictures. And don't worry, I've got an algorithm coming. And the algorithm is very kind. But for doing it with pictures, step 1 is to break it into a whole part and a fraction part. If you break both numbers into a whole and a fraction, each box should be pretty straightforward. I'll start with the hard one. I'm lying. But 2 times 1? 2. Yeah, should be pretty straightforward. 1 times 1/3? 1/3. This one's hard but easy at the same time. 2 times 1/2. What's 2 times 1/2, Ryder? 1. If that doesn't pop right into your brain, that's okay. But do some thinking on that to see how Ryder came up with that so fast. Some fractions are hard. Some fractions are hard. This question had a lot of hard fractions in it. But 2 times 1/2, well, I think we want to make that a little more friendly. We want to get to the point where we can look at 2 times 1/2 and go, oh, that's 1. Maybe there's a step in between. Maybe you have to go, maybe in your brain you have to think 2 halves first before you get to 1. And look at this. Was Could have been a mess, but it's actually friendly. 1/2 times 1/3 is just 1/6. Now, the only way that these are a little more difficult is because of common denominator. Adding those all up is a little more difficult because we got to take each section and get a common denominator. But the answer here is 3 3/6, or 3 1/2. Can you see where I got those numbers from? I added up all the stuff that was in the boxes. I added up all the areas in between. Well, if that freaks you out, maybe it should. That's not how we multiply mixed fractions normally. The only reason we're showing it to you in this particular lesson is to just start warming you up for some of the algebra that's going to come in this course and in later grades. We'll just stick our toe in the water a little bit, yeah? I don't ask any like this on the test. So if you have trouble with this question in the homework, no freaking out. Try and learn about it, ask me about it tomorrow, but no freaking out. It's just dipping our toe in the water and going, hey, can we think about stuff using area model a little better with familiar numbers, numbers that we sort of have some experience with. Any questions about that mess? Okay. I can feel it. I can hear it in your brains. You're screaming, no, wait. There's an algorithm for this. And yes, there's a beautiful algorithm for multiplying mixed fractions. Why is that blue line in there? Let's do this one with the algorithm for multiplying mixed fractions. And the algorithm is so familiar with the addition one, and so you're going to like it. If you've done any of the adding mixed fractions homework, you're going to love what I'm going to give to you here. The first step is the same first step that we talked about in adding mixed fractions. What is the first step in dealing with these? Yeah, that's what I was saying on Monday, and I don't know if I did a very good job of saying it, was that, ooh, improper, it's no good. It's an unfortunate name. It's a different way of representing fractions, but lots of times we like the improper, and the improper here is going to be helpful, so I'm going to go to improper. 5 and 5/6, okay, here's the mini algorithm for switching over to improper form. Whole times denominator plus numerator, I get 35/6. Whole times denominator plus numerator, I get 15/4. And unlike the adding fraction lesson, when we're multiplying mixed fractions, we don't need a common denominator. We don't need an extra step in here. So step 1 is improper form. And then step 2 is just go ahead and multiply them. Top times top, bottom times bottom. Ooh, 35 times 15. Listen to my brain go after this. I'm one step farther along on the mental math. And again, it's only experience and practice. It's not brain power that allows me to do this. 5 times 35 is 175. 10 times 35 is 350. So I think I get 525 up there. Could you hear in what I said some of what happened on the previous slides? Not part of this course. Nothing. Never do you have to do any of those in your head. Absolutely not. I'm just trying to give you a little bit of power maybe that you didn't have before. You always check them in your calculator afterwards though. Yeah? Especially on a quiz or test. You don't lean on mental math for a test. Yeah? Did anyone punch it in, see if I was right? You just believe me. Don't. Yeah, don't do that. Always check. And then 6 times 4, 24 on the bottom. We should be able to handle that. I don't know. I really like this way of remembering how to multiply fractions. It's so visual and nice. It's just to write n times n, d times d. Is that like, yeah, that's perfect. Or do you want the whole words there? Numerator and denominator are such painful words to write out. I like this. Just to remind yourself. Oh, multiply the tops, multiply the bottoms when you're multiplying. When you're adding, you don't go through all that. And then what's that last step? Reduce, reuse, recycle. No. Reduce, maybe. Mixed, probably. We found out in the last lesson. Sometimes we don't actually want to go to mixed. We want to keep it in proper. Ooh, 524. Oh, I can do this in my head too. Here's a challenge for you. I can do long division in my head without writing it all down. Okay? It's not that bad. 24 into 52 goes twice. That would be 48. There's 4 left over. So now I go 24 into 45. That goes once, and there's 21 left over. Give them a shot. Give them a shot. You're like, it's impossible. No, you won't know until you try. And maybe you get it wrong. And then you go, oh, what did I do wrong there? And you learn about it. 21. This reduces. What goes into both 21 and 24? So I get 7/8 here. And then you'd have to be crazy not to, at that point, break out your calculator and go, before I leave this question alone, let me just type it in. And again, tonight, this week, let's get your own calculator and start getting used to how to type it in on your calculator. I see some people still using their phones. That's no problem for this week, but we really want to get your own calculator. Not because I care about you using your phone. Actually, that's not really the point. The point is I want you to practice the calculator you're going to be using on tests so that you can get answers and you can help yourself out. I want you to do great. What is it, 5? Do I remember on my calculator how to type this in? It was only an hour ago or two. Yes, I do. 5 and 5, 6. I love this display. You can see it. It looks just like 5 and 5/6. Times 3 and, where is it? Can't even read it. 3/4. Now before I press enter, let's just talk about the two things that might happen here. One, I might get the right answer, and that's great news for me because I could put a little check mark by it myself so that when I'm going back over to check my quiz, I can go, oh, I don't even have to check this question. I know it's right. I don't have to waste time on it anymore. It could be wrong. If it's wrong, 2 choices. One, try and figure out what the heck happened and fix it. Or just leave it for now and put a little circle beside it or write a note to myself to check it later. Get the rest of the quiz or test done and come back to it. Because it's mostly right. I know it's mostly right. At most, there's a little mistake here. So I'm not going to waste my time chasing 1 mark right now. But you can do whatever you want. Let's hope it comes up right. Oh, yeah. Then you know it's right and you can move on to other things. Okay. Good. Any questions about that procedure? Is it so familiar after doing adding and subtracting? It's like identical. It's so good. That's slide 4 of 7. Well, yeah, of course you have to do one with division. First step, improper form, 30/7. Someone say it out loud one more time so this imprints in people's brain. How do we divide fractions? Yeah, flip that second one, but switch to multiply. It feels like cheating, but it's not. We've flipped the operation and flipped the fraction, makes it all work out. Top times top, bottom times bottom. And what number divides into both 90 and 35? It's obvious, isn't it? 5, yeah. So now I get down to 18 and 7. 2 and 4/7. Break out my calculator to check. 4 and 2/7 divided by 1 and 2/3. Again, if it's right, I'm happy. If it's wrong, maybe I'll leave it and move on to other things and come back to it. Or I'll track down what's going on. I get 2 and 4/7. Questions about that one? My brain is screaming that there's not 2 more slides, that there's actually only 1 more slide. Do you need more time here? I'm not trying to rush you. I want to get you to your work time. Where's our break? Oh, our break's not till 2. Oh, so I don't have to panic here. Let me peek ahead at what the next 2 slides are. Because my brain's telling me there's only 1 more slide. This one. Oh, and then the word problem. That's why. I'm going to leave the word problem out because I want you to try the word problems. I'm not going to give away the word problems. Not that I won't take them up tomorrow. I will. But I want you to have your own chance at running at the word problems. 2 1/3 cubed. This is a little dangerous with exponents. You got to be a little careful. And I'm going to show you another way to handle it. I can't remember if it's tomorrow or the next day. Very soon I'll show you another way to handle this mess. But for now, you're probably stuck with going to improper form, and then writing it out. 7/3 times 7/3 times 7/3. And I'm hoping when I do this, somebody's already going to see the shortcut you could use here on fractions. I'm not technically teaching it right here, but there is a shortcut. 7 times 7 times 7. Oh, I'll have to think about that one for a second. 7 cubed. I'll deal with that in a second. And the denominator is going to be 3 times 3 times 3, which is 3 cubed. Can you see the shortcut? I'll put a blue arrow here. Can you see how you could nicely jump from here to here? You just cube the top and cube the bottom. Totally works. I'm not teaching that today, but you know, like, you can use it if you want. 7 cubed. Okay, here you go. Listen to my brain work. 7 times 7 is 49. I know that because I know my 9 times 9 times tables. 49 times 7, I'm just going to do in my head what was on the first screen. 49 times 7 is 280 and 63. Because I said them both out loud, I can remember them, and it's 343. And 3 times 3 times 3 is 27. Hopefully you can handle that one nicely. This I didn't teach, but this is great fun. Give it a try. Especially if you're finding some of this boring. You're like, I did all this last year. I'm zipping through this homework. Yeah? I'm going to try a few of these. 3043 divided by 27. 27 into 34 goes once. 7 left over. Now it's 27 into 73. 2 and 19 left over. Oh, let's see. Mr. Todd's getting old. Are we still getting these right? Let's check. Great calculator here. Watch how this looks on the screen. 2 and 1/3. Close the bracket and put outside the bracket exponent. Look, it puts it right up there. That's so good. Exponent, what? What was it? Exponent 3 equals 12 and 19 over 27. Still got it. One of these years, I'll start to lose it. That's when I'll know. I'll retire right then, as soon as I mentally mess one of these up. So I'll just drop my, is that what I do? I just drop my pen and walk out. Head out to my sailboat and head to the lake. This is not brilliant. That's why I'm here to teach you AP, so that you're very clear that this is not brilliant. This is experience and effort. Yeah? You probably will never find out if I'm brilliant or not. What I am is effort. Try these out. See what happens in your head. Give them a go. Anybody can do them if they try. Okay? That's not what the homework is. The homework is get the answers. Yeah? Any questions here? There's a couple of fairly challenging word problems in the homework. There's a star beside one of them, 23, but there's another one. I think it's today. It's a TV or a stereo stand question with a piece of a glass door or something like that. When you get to it, it's okay if you have trouble with it, because it's tough, and we'll take them up as you need to, okay? Questions before I stop the video? Pretty happy with this? Very good.